Welcome back. Let's learn about verbal equations. Alright, so earlier in algebra, you learned how to translate verbal expressions, or words, into variable expressions, and now that you are familiar with solving basic equations from the last few lessons, we can take this one step further. We can translate sentences into equations and solve them. And these sentences can include any of the previous words and phrases that we learned that refer to the operations of addition, subtraction, multiplication, and division. And so as a quick review, before we talk about creating equations from sentences, let's review all of these different words and phrases, starting with addition. Remember that the following words and phrases refer to addition. We have plus, added to, more than, the sum of, increased by, and the total of. If you see any of those words or phrases, you are adding two values together. For subtraction, we have minus, subtracted from, less than, less, decreased by, and the difference of, or sometimes you'll see the difference between. Those are all words and phrases that refer to the subtraction of two numbers. And then for multiplication, we have times, of, the product of, multiplied by, and twice, which all refer to multiplication between two numbers, that last one just referring to the multiplication by 2. And then finally, division. There are three different phrases that we learned. We have divided by, the quotient of, and the ratio of. Those are three phrases that refer to the division of two numbers. Okay, so all of these words and phrases that we learned for translating verbal expressions into variable expressions are still in play. But for translating sentences into equations, we also need to learn a new set of words and phrases. Specifically, we need to learn how to recognize words and phrases that mean equals, which refers to an equal sign which we have in equations. And so there are four new words and phrases that you need to learn that all refer to equals or an equal sign, and that is the word is, the phrase is equal to, the phrase amounts to, and the word represents. Those four words and phrases, if you see them in a sentence, refer to an equal sign. That's going to help you create an equation from the words that you find in a sentence. Okay, so try to commit these different words and phrases to memory. You want to be able to see these and know that they refer to an equal sign. And so let's take a look at an example. Let's try translating a sentence that's going to include one of these words or phrases that mean equals and translate it into an equation. Okay, so here's our example. Let's first read the sentence. It says 3 times the sum of a number and 7 equals the sum of 2 times the number and 11. Okay, so the first thing you want to be looking for here is where is the equal sign? What two things are we equating? What is equal to what? And so you want to be looking for one of those new words or phrases. And in this case, the word that should stick out is the word equals itself, right? We just have the word equals right here. That is very clearly referring to the equal sign for an equation. So I'm going to underline that. That is our equal sign, or at least that's where it's going to be. So that means everything before it is going to be equal to everything after it. Okay, so we're going to have an equal sign, but there's going to be a variable expression that we need to figure out that will go on the left side, and then there will be another variable expression on the right side that we need to figure out. Okay, and so let's start with the left side. We have 3 times the sum of a number and 7. All right, so the first operation I see here is times, specifically 3 times something else. So that's what I'm going to write down first. We have 3 multiplied by some other value, and that other value is the sum of a number and 7. All right, so that is referring to the addition of those two numbers, whatever they are. Okay, so we're not just multiplying 3 by one value, we're actually multiplying it by the addition of two values. So put some parentheses around that addition. And what two things are we adding together? Well, a number that we don't know and 7. Okay, now if you remember from when we learned to translate verbal expressions into variable expressions, when a sentence refers to a number that we do not know, we want to assign a variable to that number. Okay, so in this case, the unknown number that this sentence is referring to, I'm going to let that be equal to n. All right, so this number that we do not know we'll call n. Okay, that's pretty standard in these types of equations. We'll use a variable of n to represent an unknown number. All right, so we have 3 times n plus 7. So we have n plus 7. All right, but now what about the other side of the equal sign? Because that takes care of everything on the left side. But what about on the right? we have the sum of 2 times the number and 11. Okay, now the first operation I see, once again, is the sum. So we know that we are adding two things together. So I'm going to write down a plus sign. But what two things are we adding together? Well, those two things are going to be separated by the word and, just like it was here, right? We had the sum of a number and 7. So we had n plus 7. In this case, we have the sum of 2 times the number and 11. So 2 times the number would be 2 times that value of n, right? We're referring to the same unknown number here. So 2 times the number would be 2 times n. And then the other thing we're adding to it is 11. Okay, so that's easy enough. We have 2n plus 11. And there we have it. We have now translated this sentence into the equation that it represents. 3 times the quantity n plus 7 is equal to 2n plus 11. And now we can actually solve this equation, right? We do need to simplify it a little bit because we have some parentheses here. But once we do that, we could solve for that unknown number of n. So let's do that here. If we use the distributive property, we can multiply 3 through this quantity. We'll multiply it by both n and 7. 3 times n would be 3n, and 3 times 7 is 21. So we get 3n plus 21 is equal to 2n plus 11. And so now, to solve for n, we probably want to combine our variable terms of 3n and 2n. So we can do that by removing one of them from one side of the equation. Let's get rid of this 2n. So we'll subtract it from both sides of the equation. So subtracting 2n will just leave us with 11 on this side of the equation because 2n and negative 2n cancel out. That's why we subtracted 2n from both sides of the equation. So this will be equal to 11. But over here, 3n minus 2n will just be 1n, right? They are like terms. Combine the coefficients. 3 minus 2 is 1. So you get 1n, which would just be n, and then you have plus 21. All right, so n plus 21 equals 11. But now we can solve for n by getting rid of this constant. So what we want to do is subtract 21 from both sides of the equation. All right, and so then 21 and negative 21 cancel out. So what you'll get here is n is equal to 11 minus 21, which would be negative 10. So we get n equals negative 10 as our final answer. That is the solution to the equation that we translated from this sentence. And if you wanted to, you could check to make sure that this is the right solution by plugging it back in for n in the original equation and see if you get a true statement. I'm not going to go through that work here in this video. I've shown you how to check solutions many times over in previous videos, so I'm not going to spend the time on that in this video, but I will tell you that n equals negative 10 is the correct solution to this equation. All right, now before we look at more examples of translating sentences into equations and then solving them, there is another type of problem you might encounter when translating sentences into equations. And these are what we call consecutive integer problems. Sometimes the sentences you need to translate into equations can get a little bit tricky by instead of just referring to any unknown number that you want to solve for, they may be more specific by describing a type of integer. And so it's important that you remember what an integer is. Integers are just whole numbers, and that includes both negative and positive numbers. So examples would be negative 3, negative 2, negative 1, 0, 1, 2, 3, right? These are all integers because they are whole numbers. There's no decimals, no fractions, just nice and easy whole numbers. Okay, so when a sentence is talking about integers, these are the types of numbers it is talking about. Now, more specifically, a sentence may refer to even integers, which are just integers divisible by 2. Numbers like negative 6, 0, 4, 12, those are all numbers that can be divided by 2 evenly, right? Meaning that the result is another whole number or another integer. Now, on the flip side of that, a problem could also refer to odd integers or numbers not divisible by 2. So that would be numbers like negative 7, negative 1, 3, or 19. Any number that is not even, meaning that when you divide it by 2, you do not get another whole number. Those would be integers that are odd integers. Okay, so you might see sentences refer to integers in these ways, but sometimes they might complicate it even further. For example, a sentence may refer to an unknown set of consecutive integers, which just refers to a couple of integers that would follow one another in order. For example, think of 8, 9, 10. Those are numbers that come right after each other when you think about how you count through numbers, right? You go from 8 to 9 to 10, or another example would be -7, -6, -5. Those are sets of consecutive integers. And it's important to recognize what that means, right? What consecutive integers are, because if you don't know a set of consecutive integers in a sentence, you can represent them using a variable. Assuming that we let our variable n represent an integer, you can represent a set of consecutive integers like this. You start with that value of n, and then you add 1 to it, then 2, then 3, then 4, then 5, and so on, right? n plus 1, n plus 2, n plus 3, and so on would represent a set of unknown consecutive integers. This can be helpful in solving consecutive integer problems. But now in some cases, these problems might get more specific. Not only will it be interested in consecutive integers, but it might be interested in consecutive even integers. So numbers that follow one another, but only the even ones. You skip over the odd numbers in the order that numbers would be written out. All right, so for example, 20, 22, 24. Notice that we don't include 21 or 23. We skip over the odd numbers and just look at consecutive even integers that are listed in order. All right, and so when you don't know a set of consecutive even integers, you can represent them using a variable, just like we did for regular consecutive integers. It's just that in this case, notice that each number is separated by a value of 2, right? From 20 to 22, that is a difference of 2. If you add 2 to 20, you get to 22. And then if you add another 2, you get from 22 to 24, and that pattern would continue. You could get the next consecutive even integer by adding another 2. That would get you to 26, and then 28, and 30, and so on. So we could also represent that with an unknown variable n. If we don't know a set of consecutive even integers, we could represent that like this. You have some number n, and then that number plus 2. And then that number plus 4, and then that number plus 6, and so on. You just keep adding an additional 2 to each previous number to get the next consecutive even integer, okay? Just like in our regular consecutive integers case. Each number was separated by a value of 1, so we represented that by n, then n plus 1, then you add another 1, so n plus 2. The same idea here. Each number increases by 2. Assuming that that value of n that you're starting with is an even number itself, right? N must be an even integer to begin with. And that's the assumption that we would make when we write out this list of unknown consecutive even integers, okay? And that assumption is important because a problem might also refer to consecutive odd integers. And so this is the same idea as consecutive even integers. It's just that instead of looking at the even integers in order, we are looking at the odd integers in order. So for example, 19, 21, 23. We're skipping over 20, we're skipping over 22, we would skip over 24 and go to 25, and so on. You're just looking at the set of odd numbers where they are written in order, okay? You just skip over those even numbers. And what I meant by that assumption being important for consecutive even integers, that n had to be even itself, is because you would represent consecutive odd integers the same exact way. Notice that all of these numbers are just off by 2, right? 19 plus 2 is 21, 21 plus 2 is 23. So just like with consecutive even integers, consecutive odd integers are just a value of 2 apart. You can add 2 to an odd integer to get the next odd integer. All right, so you would represent an unknown set of consecutive odd integers with n plus 2, n plus 4, where that first value of n is assumed to be an odd integer, okay? If n is odd, then adding 2 to it, or 4 to it, or 6 will always give you another odd integer, okay? So for our example here, if you think of n as being 19, n plus 2 would be 19 plus 2, which is 21, n plus 4 would be 19 plus 4, which is 23, and so on. Okay, so both consecutive even integers and consecutive odd integers are represented the same way when we don't know them, or when we don't know a set of those numbers. Okay, so when you see a problem refer to consecutive even or odd integers, and you don't know what those numbers are, this is how we would represent them. That is what you're going to do if you are translating a sentence into an equation that involves a set of unknown consecutive integers. All right, and so let's look at an example problem where we use these ideas in action. Hey there, real quick, before we get to the next part of this lesson, If you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. For this example, we have the sum of 3 consecutive odd integers is 45. Find the integers. Okay, so this is exactly what I was just talking about. We're given a sentence that refers to consecutive odd integers, and we don't know what those numbers are. In fact, our goal is to find them. And so you want to be able to know how to represent those consecutive odd integers using a variable. All right, so let's try to do that here. Notice that we're talking about 3 consecutive odd integers. So in order, remember that we would represent that like this. We would have some variable of n. That would be our first odd integer. We're assuming that n is odd. And so that means that the next one would be n plus 2. We add 2 to our previous odd integer to get the next one. So that would be 2 consecutive odd integers. And then the third one would be n plus 2 plus another 2. But 2 plus 2 is 4. So that's how we get n plus 4 as the third and final consecutive odd integer, okay? And once again, we are assuming that n, that unknown number, is odd itself, all right? So those are the 3 numbers that we're trying to look for here. Those are our 3 consecutive odd integers. But what we are told about these 3 numbers is that their sum is 45, all right? That word is refers to an equal sign. Right? Remember from the beginning of this lesson, is one of the words that refers to equals. That's going to help us set up an equation that this sentence represents. All right? Now, what is equal to what? Well, the sum of these 3 numbers is equal to 45. All right, so we would have n plus 2 plus n plus 4, and that will be equal to 45. Right? These are our 3 consecutive odd integers. We're just taking the sum of them, which means adding them together, and we know that that must be equal to 45. So now what we can do is solve for n in this equation and use that value of n to help us find the 3 consecutive odd integers. We just have to do a little simplification on this side of the equation and then solve for n like we've solved for any other variable in an equation in the past. Okay, so let's begin by adding everything together. We don't need these parentheses here. I just wrote them in to clearly show you each odd integer, but really what we have here is n plus 2 plus n plus 4 equals 45. Okay, since everything here is addition, we do not need those parentheses. If there was a subtraction sign, you would need to be careful because you would want to distribute that negative to all the terms in each quantity, but that's not the case here, so don't worry about it. Now what we want to do is combine our like terms, and we have 3 terms of just n, so we have n plus n plus n, that is 3 n's, so you would get 3n, right? Each of those n's has a coefficient of 1, and 1 plus 1 plus 1 is 3. So you get 3n. That is the result of adding these 3 variable terms that were like terms. And then we also have 2 constants of 2 and 4. 2 plus 4 is 6. So we get 3n plus 6 is equal to 45. Okay, so now we just have one variable term. So we want to isolate it so we can solve for n. So we need to get rid of this constant of 6. So let's subtract 6 from both sides of the equation. 6 and negative 6 cancel each other out. And then 45 minus 6 is 39. So we get 3n equals 39. Now, to solve for n, we just need to divide both sides by that coefficient of n, which is 3. So if we divide both sides by 3, those 3's will cancel out because anything divided by itself is 1, and 1 times n is just n. And so this gives us that n is equal to 39 divided by 3, which is 13. So we get n equals 13 as the solution to this equation. However, that's not our final answer. Remember that we want to find the integers, specifically the three consecutive odd integers. This is one of them, because one of them is just n, but then there's two others that we have to find as well. Okay, so we found that one of them is 13, because n is equal to 13. But then what about n plus 2? Well, n plus 2 would become 13 plus 2, because we just found that n is equal to 13, and 13 plus 2 is 15, so we get 15 as the next one. And then you could add 2 again to get the next one, or you could just use our expression here of n plus 4, where n is 13. So if we did that here, you'd have 13 plus 4, and 13 plus 4 is 17. Okay, once again, you could have found that answer as well by just adding 2 to 15, because each consecutive odd integer increases by 2. We go from 13 to 15 to 17. Okay, and so there we have it. Those are the three consecutive odd integers whose sum is 45. And you could check that if you wanted to. You could check the work here. Let's see if 13 plus 15 plus 17 really is 45, like it should be. If you add 13 and 15, you get 28. So this is equal to 28 plus 17. And then 28 plus 17 will give you 45. All right, so that does check out. Our answer is correct. 13, 15, 17 are the three consecutive odd integers whose sum is 45. Okay, so we're done with this example. That is how you solve a problem like this that's talking about consecutive integers of some kind, and your task is to find those integers. This is how you would do it. You just need to be familiar with how to represent those unknown integers with variable expressions. Okay, let's take a look at one more example for this video. All right, so for our final example, we want to find two consecutive even integers such that 5 times the first integer is equal to 4 times the second integer. Okay, so this one's a little bit more involved. And so let's just start by writing down how we're going to represent the two consecutive even integers that we don't know. All right, we're being told to find those two consecutive even integers, so clearly we don't know them. All right, so let's just call the first one n, right? Our first even consecutive integer will be n, which means that the second one will be that value of n plus 2, right? We're talking about consecutive even integers, not just consecutive integers in general. We're only looking at the even ones, so to get the next one, you have to add 2, not just 1. Okay, so the second consecutive even integer will be n plus 2. Now specifically, those two consecutive even integers should be such that 5 times the first is equal to 4 times the second. All right, now this is very important because this part is giving us an equation that we can set up. We can translate this into an equation that we can then solve to help us find these two consecutive even integers. And the first thing that should really stick out to you is this phrase of is equal to. Remember from the beginning of this lesson that we said that that refers to an equal sign. So what that means is everything before it, which would be 5 times the first integer, will be set equal to everything after that equal sign, which is 4 times the second integer. Okay, so we're going to have an equal sign, but then on the left side we'll have 5 times the first integer, so 5 multiplied by n, so we'll have 5 times n, and then on the right side of the equation we have 4 times the second integer, so 4 times n plus 2. And be careful here, don't write it like this, 4n plus 2, that would be wrong. You want to write 4 multiplied by that entire number. So you want to have 4 times n plus 2 in parentheses, okay? Don't just multiply 4 by n, you want to multiply it by that whole number of n plus 2, okay? And so now we have an equation that we translated from this sentence, which we can now solve and get a value for that variable n, which will tell us what the two consecutive even integers are, such that 5 times the first is equal to 4 times the second. So let's solve this equation. The first thing we need to do is get rid of those parentheses. So let's distribute 4 through this quantity. We need to multiply 4 by n and 4 by 2. So we'll get 5n equals 4 times n, which is just 4n. And then you'll have 4 times 2, which is 8. So we have plus 8. All right, now at this point we have two variable terms that involve that variable n. So let's combine them. Let's remove one of them from one side of the equation. I'm going to get rid of this 4n on this side. So let's subtract 4n from both sides of the equation. If we do that here, 4n and negative 4n will cancel out to become 0. And then 5n minus 4n, 5 minus 4 is 1, so you'll get 1n, which is just n. All right, and all we're left with on the other side of the equation is 8. And so now we're done, actually. There's nothing else for us to do, which is nice. We have now just solved the equation and found that n equals 8. But we're not quite done yet, because while 8 would be the first consecutive even integer, we still have to find the second one. All right, we found that n is 8, but then n plus 2, that would be equal to 8 plus 2, because we just found that n is equal to 8. And 8 plus 2 is 10, so that becomes 10, which means that the two consecutive even integers that we wanted to find here are 8 and 10. Okay, so I'll just write those in a row here. 8 and 10 are the two consecutive even integers such that 5 times the first is equal to 4 times the second. And if you wanted to, you could check that. Remember that 8 is the first integer and 10 is the second. So 5 times the first would be 5 times 8. If you want to check your work here, 5 times 8 should be equal to 4 times the second integer, so 4 times 10. All right, and is 5 times 8 equal to 4 times 10? Yes. 5 times 8 is 40, and 4 times 10 is 40, so you get 40 equals 40. That is a true statement. That checks out, so our answer here is correct. We found two consecutive even integers where this statement is true. Okay, and so with that, that is it for this example. And this was also the last example for this lesson video. But if you do want to get some more practice, feel free to check out my examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now. So I will see you next time.